So here we're going to look at word problems. And the math is going to nothing new at all with the math part. But with word problems, sometimes you have to do that first step. You have to draw the diagram. And let me just say, on the homework, on this one, I'm also going to modify for you. I'll tell you what that is at the end of the notes. And there's going to be a lot of word problems. When you do the homework, you do not have to copy down the word problem. You just have to draw the diagram and show the work, okay? So don't worry about copying down a word problem at all. Let's take a look at this picture here. So if we have an angle of elevation, an angle of elevation is formed by kind of like a line of sight and the horizontal part of this picture here. So you got your line of sight here and the horizontal picture. So if we're talking about angle of elevation, and we will, it's usually the base angle. So when you draw a right triangle, you'll have your base here. One of them will be a 90-degree angle. The other one will be what we call the angle of elevation. And so that picture kind of goes with the first word problem. And so we're not going to do too much on this one. We'll kind of do this one together. Casey is at the site's the top of an 84-foot lighthouse. So here's our 84 feet, right? And Casey's 6 feet tall, right? And what we're interested in working with here is the actual triangle. And so if we can get a side length of that triangle, that would be helpful. Angle of elevation is 58 degrees, so that would go here, 58 degrees. How far is he standing from the base of the lighthouse? So that's talking about this distance here. So there's our variable x. But we need another piece of information here. Anybody tell me anything else about this triangle? Yeah. Which is? Yes. He's like this. Yeah. Okay. Um, so yeah, you subtract the 6 from the 84, and you get 78. So 78 would be kind of the height of that triangle. And then it's set up. So being able to set up that without, like here, there was a lot of help for us. So we're going to practice setting up these, because if we don't start with the right picture, we're not going to end with the right answer, right? And so I'm not going to take a lot of time going over solving right now, but more setting up. And so number 2, I want you to read the problem and just set up the diagram. You don't have to solve it. On the homework, you will have to set it up and solve it. But right now, we're just going to focus on the setting up part. So see if you can draw a correct picture or diagram that would go with number 2. And so on number 2, you should have some kind of right triangle here. So we got angle of elevation from a kicker's foot to the on a football field to the top of the goalpost, right, is 17. So here's where the foot of the football player is. Here's where the top of that goal post is. And so this is the angle of elevation here at 17 degrees. He's standing 131 feet from the base of the goalpost. So here's 131. That's your horizontal distance. And then the question is, how tall is that goalpost? So this is where our variable would go. So if you have a picture like that, you started right, and you're off to a good start, and you would finish that problem. We don't worry about doing that right now, though. Try reading number 3 and drawing a diagram for that one now. So here we have a setting where we have a slide at the playground, right? So here's the slide is at the angle, right? So it's going to end up, the slide is going to be our hypotenuse of this triangle. And notice that it's asking you to find the length of the slide. So your variable should actually be the hypotenuse of the right triangle. It says that the angle of elevation to the top of the slide is 46 degrees. So that's your base angle right here. And the height of that slide, so the vertical height, is going to be 9 feet. So something like this would be how you want to start. Hypotenuse should be x, 46 degrees here at the base. 9 should be opposite the 46. By the way, we have a little, okay, I'm just going to put it here, but so if we have, in general, you got to know this vocab. So if I'm talking about the distance from A to B, this would be the distance. But if we form a right triangle here, this is called your horizontal distance. And this right here would be called the vertical distance. So you have your actual distance from one point to the other, but then that's made up of two components. And if you get into physics, they really break this down further. But you have your horizontal component and your vertical component here. And so you'll see in the as you read through these word problems, some will say the horizontal distance, some will talk about vertical, like vertical height here. You'll see those words come up. And just having that in the back of your mind will help you with some of these. Okay. All right, try number 4. Read it, draw a diagram. So a dog is standing 5 feet from the base of a tree. So here's your dog, here's the base of the tree. It's your 5 feet. Looking up at a cat that climbed up the tree. So okay, here's your cat, and the dog's looking at that cat. So here's your angle of elevation. Cat climbed up 16 feet, and we're looking for that angle of elevation, x. So that's the picture we're starting with. We got our 90-degree angle here. Okay. I need to solve for x, so I'm going to draw a similar triangle, a scaled down version with a hypotenuse of 1. Same angle measurements. So this is the sine of x, and this is the cosine of x. And we're working with 16 and 5, and they correspond to sine and cosine. So I'm going to use tangent. So set it up, sine over cosine would be 16 over 5. So that's tangent is 16 over 5. And because I'm solving for the angle, I'm going to have to use the inverse. And what are we getting? 72.6. And because it's a word problem, look for units. Degrees. It's an angle, not feet, right? Degrees. Okay. All right, turn the page. So the first ones were on angle of elevation. There's also another angle that we refer to called the angle of depression. Not as positive. So I want you to look at this picture we have here. And I'm going to highlight our right triangle here. And I want you to notice that the angle of depression is not inside that triangle. It's actually on the outside. So the angle of depression, when we're solving a triangle, we actually want the angles to be inside the triangle, not on the outside. But we can easily get an angle inside. So one way, and I want to make a connection for you here. So if you're referring from the guy at the top looking down, you got the angle of depression. If you start low and look up, that's your angle of elevation, right? And so if you take the perspective of that swimmer, you see where the angle of elevation would be? Right over here, right? Would it be inside the triangle? Yeah. Angle of elevation is always inside that triangle. Angle of depression is not. Can anybody relate the two angles in some way? Yes. CJ. Oh, you sure? They are. So that means they are congruent because we have parallel lines here, and And so they are alternate interior angles. So whenever you hear angle of depression, just think, well, that's also my angle of elevation. Okay, so that's nice. And the angle of elevation is what's inside the triangle, and we can work with that. So we're going to skip 5 because they already have the diagram for 5. But take a look at 6 and read it and draw a diagram to go with it. You don't have to solve 6, just set it up. All right, so here you have a helicopter flying around, spots this landing pad somewhere below. Okay, and so we're going to get this right triangle here. I'll put H, here's my helicopter, L for landing pad. And it says the angle of depression is 73, so the angle of depression is really right here, 73 degrees. But that's congruent to the angle of elevation, which is right here inside. So the base angle side. The horizontal distance, there we go. That I was telling you, horizontal distance, that is right in here, is 1,200 feet. And what's the altitude? That's your vertical distance. And so that's where x would go. Okay. So if you have that, then you're on the right track and you to a right answer. Okay. 7's a little more confusing. Try it out. See what you can do. All right. So you got 2 buildings, building A and building B. Building A is a little shorter, right? You got this disappearing building here. See. Okay, so building A is 480 feet tall. You got building B, 654 feet tall. And we're looking from top of building B to top of building A. And so top of building to top of building. Okay, so that's your line of sight there. This is the right triangle we're looking at. So you have this piece here. We're looking for the distance between the buildings, so that would be the horizontal distance in my right triangle. Let's see, what else can we get from here? So the angle of depression is 42 degrees. That's this angle here looking down. But it's also from the other frame of reference, if we were on the smaller building looking up, that would also be 42 degrees here. Okay. And can we get anything else here? There's actually one more really important piece we need to get. Yeah. So subtract 480 from 654, and what do we get? 174. And that is the height of our triangle. And now we can work with this to find x. Okay. All right. Last one, 8. I want you to do everything with. So I want you to draw it, solve it, from start to finish. All right, so here we have a lookout tower that Zach is standing on top of, 75 feet tall. We're kind of ignoring his height. Angle of depression, so he's looking at spots of water fountain. So let's say right over here, he's looking down at it. So we get our right triangle here. And he's looking down, so that's the angle of depression here at 28 degrees. If you were at the water fountain looking up, that would also match it, 28 degrees here. And we're looking for the horizontal distance, x. And I said to go ahead and solve this one. So then we set up a smaller version, a similar triangle with a hypotenuse of 1, same angle measurements though. This would be the sine of 28. This would be the cosine of 28. 75 and x is what we're working with, so sine and cosine is what we're working with. So sine 28 over cosine 28, 75 over x, that's tangent. 28 over 1 is 75 over x. I'm going to cross multiply x times the tangent, 75, and divide 75 over tangent 28 degrees. And that is going to come out to be about what? 141.1, and then units are feet. Okay. So, I was going to modify the homework. I want to show you that. We have two homeworks, right? You were working on the first one already. The second homework, we're going to take out 1 through 4. Start at 5. So you're just going to do all the word problems on the second homework. So 5 through 9. You're not going to copy down the words. You're going to do it on a separate sheet of paper, and you're going to just draw the diagram and solve it. Okay? And you have lots of time to get a lot done. Okay? 5 all the way to 9. In Gradescope, there's 2 different submissions, one for section 3, one for section 4. But before we go too far, we have a birthday, Zoe, and so we got to celebrate that. Definitely. You came back on the right day, Zoe. Zoe. All right, there you go, guys. Happy birthday, Zoe. Have a good day today. Take run. Okay, so work on your homework.